السلام عليكم جميعا. Thank you for being here today. I'm going to switch over to English. أي أحد يبغى يسأل بالعربي ولا الإنجليزي feel free to do so. For the live stream, I'll be switching over to English. My name is Ibrahim العثمان. I'm a customer engineer at Google Cloud. I've been a customer engineer at Google Cloud for the past 4 years. My main role is covering the energy and high-tech sectors within Google. Of course, my specialization branches across many areas or many domains within Google. But today we'll be focusing mostly on retrieval augmented generation. I'll be deep diving into it a little bit. Before we start, I would just want a raise of hands. Who knows what RAG or retrieval augmented generation is? RAG. Good, okay. I can't see who's on the stream, so I'll just assume that no one knows as well. No need to do a further introduction, but I'll jump right into it. So, who here uses AI? ChatGPT, Gemini, it doesn't matter. Who uses it? Raise of hand, okay. How often does the AI hallucinate? Like, who had the hallucination from an AI when they talk to it? Good, okay. What's a hallucination? Maybe I'll elaborate a little bit on that. Or if someone knows what a hallucination is, you can raise your hand and answer that if you want. No one? You know? Go ahead. Hallucination? اي هلوسة. والهلوسة بالنسبة للAI إنه يشطح لك answers من عنده. Hallucination is a big problem. It's always been a big problem. And since generative AI or large language models is relatively new, big part of the work that the industry or the ecosystem has been working on is to reduce the amount of hallucinations, especially as you start to apply AI in highly risky use cases. Let's say banking, say healthcare. Hallucinations cannot exist in these sectors. This is where retrieval augmented generation was invented, let's say. It wasn't invented rather than retrofitted to fit large language models. Retrieval augmented generation is telling the LLM, don't come up with stuff yourself. There's data sitting somewhere. Rely on that data to come up with your answers. But the large language model is not ready to read thousands and thousands and thousands of words and letters and try to understand it. That will probably cost millions and billions of dollars. This is why RAG is the easiest way to make an LLM grounded. Grounded in reality, grounded in truth, grounded in data. Typically what happens, in the normal sense of large language models, none of this exists, this middle part. What happens is you have a question and you ask the LLM. And then the LLM spits out an answer. What's the answer? Whether it's true, not true, doesn't matter. Spits out an answer. And then more recently, you start probably seeing when you pop a question to the LLM, you get an answer and then some sources at the bottom saying, oh, this is Google search. This is from this website. This is from Wikipedia. And this is typically one transformation from a regular LLM to a RAG-enabled LLM. When you start seeing the sources, when you start seeing more accuracy from the answers, it's probably because that provider has implemented a RAG system. And it goes deeper. A lot of the enterprises today in Saudi, outside, they leverage RAG to make sure that they can roll out large language model and AI use cases within their organization without risking the LLM destroying the entire business because it came up with the wrong answer or gave the customer the wrong impression or gave the patient the wrong assessment. So from the left, I'll start to explain a little bit about embeddings and what RAG means. RAG stands for Retrieval Augmented Generation. Retrieval Augmented Generation. Retrieval of the data, augmenting the answer, and generating the final answer based on that data. Typically what happens, a question comes in. Instead of it being in pure text, I send it to something called an embedding model. The embedding model is also a large language model. So when you look online for embedding models, you'll find the typical models out there, doing versions of them doing embeddings and versions of them doing actual generation. Why is this? Because the embedding model, you insert text and it outputs numbers. It doesn't output text, it outputs numbers. And the idea behind the embedding model is to create a vector, a representation of the relativity between different words, different things, different images, and they sit in a vector. What's a vector? If anyone had physics 1 in university, it's the three-dimensional area where you have points and 3 numbers representing the point within the dimension. And that is what a vector is. So what I do is, I send a question to the embedding model. The embedding model converts it to numbers, a representation of a vector, based on a predefined knowledge base that I chunked up, broke down, and gave it to the model, and the model transformed it into numbers. And then those numbers got stored in a vector database. A vector database, there's a lot of vector database options out in the market. From the typical MySQL kind of plugins that you can enable vector databases in, to the more managed options. And then of course these vectors, so let's leave the question here aside. Those vectors are brought in from the knowledge base into the vector database, and then what I do is a content index, which means I rank the answers, or I rank this information within my vector database to make sure that my retrieval is more relevant to the use case that I have. So that kind of explains this section over here. Now as I go over the rest of the pipeline, we'll go bit by the ingestion, to the retrieval, to the generation. So ingestion is the first step. You want to build a RAG, you have to think about populating your vector database before you serve any customer. So before you serve any client, you come up with a knowledge base. You're building a use case for healthcare, your knowledge base should be the patient records, or let's say information from the hospital regarding diagnoses, do's and don'ts, medicine that's available, not available. Then you chunk it into small bits and pieces, because you can't put the entire knowledge base into the embedding model. It can only have a certain amount of tokens that it can ingest every run. Tokens represent the amount of characters, let's say, that can be ingested by the model itself. And usually embedding models are very, very, very small. Then, once those chunks are converted into vector representations, they're stored in the vector database, and then you run a indexing operation across that data to make sure that you have them in the right manner. So now I ingested the data, and I put it in the vector database. Now me as a client, or a user, or a customer, I ask a question to your AI application. My question should not go directly to the large language model. What happens is my question, just who is this person question mark, will go directly into the embedding model. It's an endpoint. You talk to it. It will convert that question, who is whatever, to numbers, 2, 3, 4, 5 in a dimension. And then it will go through the vector database to check which numbers are closest to the question numbers, the vector of the question, which one is closest to it within the vector database. So say, oh, this section is closest. Who is Ibrahim? And I've chunked my profile into chunks, embedded it, and put it in the vector database. So if I ask who is Ibrahim al-Uthman, it will go and see that the vector representation of the question is next to the vector representation of my name and my profile. Then what it does is that it will convert that vector back into text and then answer my question. So in this case, if this does not exist, I might ask, who is Ibrahim al-Uthman? I might go and search online, go back in time. There's a lot of Ibrahim al-Uthman. There's Ibrahim al-Uthman al-Qasim, Ibrahim al-Uthman al-Hasad, there's a lot of Ibrahim al-Uthman. Unless I have a knowledge base that has the specific Ibrahim al-Uthman that is specific to this use case, it will always generate a different answer. So that is why RAG is needed. And then finally, the answer itself, since I convert that vector back into text and I combine it with the question, then maybe I populate it a little bit more, the LLM adds a little bit of spices and then provides the answer over to the user. So now that we kind of talked about the pipeline, I'll jump a little bit into the tools that you as developers can use to do all of this. Whatever is in blue, you can do on Google Cloud natively. Okay? Whatever is in blue, Google Cloud natively or out of the box. Whatever is in yellow or orange or whatever color you see here, it's DIY. Do it yourself. I'll start with the Google Cloud side. So we talked about ingestion, right? Which requires data sources or a knowledge base. And that knowledge base can be in unstructured data, PDF files, images, picture, doesn't matter. Or it can be structured, a table, database. Whether it's SQL, using Cloud SQL, whether it is NoSQL, using Bigtable, Firestore, or even maybe a data warehouse that you're leveraging. Once I have this data source, what I'll do is start chunking it. And using something like Agent Builder, we do most of that stuff for you in the background. You just have to point the Agent Builder to the data sources. We'll do the chunking, we'll do the embedding, we'll do everything, including making sure that the AI model uses those embeddings to be able to leverage that. Is it a... Okay. Now, okay, what if you don't want to use GCP or the items that are available in it? You can also use some DIY ingestion, such as using a parser from LangChain, LlamaIndex. Those are open source tools that are available. LangChain is very common for building agents, same for LlamaIndex. What you do is you parse that data, so that this connector, you would write it in Python or any other coding language. Usually Python is the easiest. You would point it to the external data sources over here, pull it in, bring it into a parser, either Document AI, which is available by Google, but if you want to do a DIY, you have parsers available also in the open source community. Chunk it, and then you use embeddings, whether it is on Vertex AI as the embeddings API, which provides an embedding model for you to leverage, or you can go leverage something like Quinn, which is one of the top models, open source, and one of the top embedding models out there. It's actually ranked next to Gemini when it comes to embeddings. And then, of course, once those embeddings are generated, you would store them in any kind of database, vector storage, whether it is BigQuery, vector search, which is available by Vertex, or you can go and deploy your own database, MySQL or something like this, and use the plugins for vector database. So one of the most commonly used ones is like Postgres PG Vector, which can be leveraged to store these embeddings. So now we're done from ingestion. One using out-of-the-box Google Cloud, and one using DIY tools. The blue section that I just mentioned to the left is actually this, which is our agent builder, search data store. You go into Vertex, open the console, you'll find it there. It will just ask you to pinpoint to your data sources. It asks you for websites, PDF files, images, anything you want to add, and then it will just take everything and chunk it, embed it, and store it in the data store. Another approach is if you're going to do a DIY path and build your own thing, and you don't want to go through the hassle of deploying your own embedding model. We have something called the Embedding API, which is one of the top in the industry. And the idea behind it is that it runs our embedding models, and it allows you to call the API with the data and create the vector representations of that data. Of course, supporting many task types, So when we look here at like a retrieval query, retrieval document, each task maps to a different use case. And the deeper you go into embeddings, the more you'll understand about the different tasks, but we will not delve too deep into the different tasks here. Also, another approach if you're doing DIY, which is, again, DIY is the opposite of using Agent Builder on Google Cloud. You can leverage any of these databases, vector databases, including, but not limited to, using PostgreSQL on Cloud SQL or using it on a normal virtual machine configured by yourself, but it's a lot easier to do it this way. And of course, there's a huge, let's say, differentiating factor that you have to keep in mind when you're choosing which database to store your vectors. One very important factor is the max vectors per search space, max dimension per vector, max vector storage capacity, and finally, latency. Most of the consistency is the same across all of them, but it's very important to note these parts, because this determines what kind of data sources you can actually embed. Some data sources might take a lot more, some data sources might take a lot less. For instance, like text versus images versus videos, each of them has a different approach to how the vectors are represented. Latency is also important because it matters with the generation of your answer. Whatever you have here, you can almost double it. Why double it? Because I go one way when my question comes in, and I go another way when my question comes out, because the embedding model has to work twice. Now let's talk about retrieval. I ingested the data, I put it in my embedding model. Now it's time for me to retrieve that. So as a user, I have two paths. If I'm going with the out of the box with Agent Builder, I would just go query the app. Agent Builder usually deploys a front-end application for you. You can also call the API and front it with a different front end. And then the query would come into the app. The app would go talk to the data store, which the data store, as we discussed just now, holds everything from the vector representation to the embedding model to everything you need. And of course, it talks to a connector, which has an access list, because if I have a use case where I'm getting a lot of confidential data in the company, and only specific people need to have access to that specific data, I can't generate an answer for something that's confidential. So I need an ACL check, and this is what happens with the out-of-the-box Agent Builder. But that is why in the DIY path, it gets a little bit more complex. But why would I go for, I did not delve deep into this. Why would I go for DIY versus out-of-the-box? Out-of-the-box is easier, but maybe not customizable or flexible enough for your use case. Out of the box might end up being cheaper than doing it DIY. DIY is the most flexible. It can potentially be cheaper if you want it to be, but it can get complex very, very, very fast. Especially if you are the type of developer who has analysis paralysis. What's the best library here? What's the best module here? And I keep checking, refreshing GitHub and refreshing all of these websites, just checking how should I configure it or program it. And typically in businesses, spending 6 months in here and spending 1 week in here to develop it is a very easy choice to make. It's 1 week here, 6 months here, I'll go with this if the business wants to go fast. But let's say maybe you're building a startup. Then maybe relying on out of the box is not necessarily the best option. Because if the core of your startup is the flexibility or customization of this and you have a lot of developers working on it, DIY is probably the only path for you. And on Google Cloud, we support it with a lot of products. We don't restrict it to one area. We rather support all of them. And actually, we contribute to most of these open source libraries and tools. So from the DIY path, the user query has to come through to your serving front end, normal front end. It should take the question, maybe rewrite the query if necessary, if the query is not well written, create an embedding of that question, search through the different vector databases that you have, retrieve the similarity search, getting the text back, and then generating back the answer to produce back to the user. But now that we talked about the retrieval, if I don't have a way to understand the information that I have stored, or at least to have a ranking system for it, let's say I go into the entire knowledge base of my business or my company, and there's thousands and thousands of documents. But typically in any company, you have thousands of documents, but maybe only 10% of them are used daily, while the rest of the 90% are useless because maybe they're old, maybe they are outdated, the process changed. So this is where ranking comes in the retrieval path. So if I create a query and I go through the retrieval path, it will go to the vector database, it will search through the entire vector database, it will probably find maybe next to the vector, my questions vector, they'll probably find 3 different representations that are the same rank. How will it make sure to retrieve the right one for me? This is where ranking comes in. Ranking is done by making sure that the answer, when the answer is good, haven't you noticed, who noticed in the answers of the most common LLMs, there's a thumbs up, thumbs down on the answer, and it's kind of a hidden way for them to do this process. So when you say thumbs up, it means it should put that vector database, vector retrieval of that vector representation as number 1, or rank it up. If you put thumbs down, it lowers it down in the priority. And what that does is that when I send the query again, the response is going to happen a lot faster, because the ranking allows the vector representation of my question to be a lot closer to the things that are ranked at a higher level. Okay? So this is what ranking does, and ranking API is a Google Cloud API that allows you to do that. And of course, you can do it on a DIY path, but this is also a DIY path enabled architecture, but with the API being kind of an easier implementation of it. Finally, the generation. We talked about the query back then with the retrieval. The question comes in, a vector representation comes out of it. We go into the vector database. But now I want to generate. So I get the vector representation and the text representation of it. In the DIY path, my agent will get back the representation of that vector as text, and then will call the endpoint. It will call the big large language model, the one that's actually running the use case. And then will reason and respond back to the user. Same thing happens with the agent builder, just a couple of steps. But here, it jumps through a few steps to be able to generate this response. Some more advanced architectures is using several different types of models for different types of use cases. So if someone's asking about sports, maybe this model is better. If someone's asking about an image, maybe that model is better. So it's okay with an agent and a RAG system to have several models in the backend supporting you. But the embedding model typically has to be one embedding model. You can't mix a lot of embedding models. Does anyone know why you can't mix several embedding models? With a raise of hand, maybe. Yes, please. Exactly. ومو بس هلوسة. ما يصلح موديل يتكلم انجليزي وموديل يتكلم عربي. ما راح يفهمون على بعض. كل واحد يطلع الارقام حقتها. So if I ask the embedding model what is the representation of hello, it will say 1. If I ask another embedding model what's the representation of hello, it will say 2. So if I have a combo of embedding models, each will give me a different answer. So it always has to be 1. At least, if you have the logic set up in your front end, you can probably do 2, as long as you know how to separate between the different queries and different questions coming from the user. but typically one is always the option. And then of course, using the different generative models to do the full answer is always recommended. So with generation within the ecosystem of RAG and GCP, definitely we have one of the most advanced generative foundation models, as you might be well aware of, Gemini 2.5, and with the upcoming new versions that are coming out, in addition to different foundation models to do images, sound, also embeddings, to task-specific models, to even partner on open ecosystem models like Llama, Claude, and the rest. And all of this is available in Vertex AI Model Garden, which is also available in Google Cloud Dammam. Another thing is, regarding these models, is Gemini 2.5 Pro currently ranks #1 alongside Claude, Opus. In addition, when it comes to hallucination, it ranks at second and third. Actually, was the #1 up until a few weeks ago. But of course, with the typical way of the market going, every day a new rank comes out. And as you know, Google is usually on the lead. Another thing is the grounded generation API. And since the vector database is something you build, you have to configure, you have to set up the system likewise. We also have the grounded generation API, which allows you to go and leverage Google search to augment your answers to your users and to your use case. And this is also available both for the out-of-the-box and the do-it-yourself path. So you don't necessarily have to go with the full stack of Google Cloud. You can pick this API to use it for a specific use case, which is grounding it with Google search answers, or even different sorts of systems they can use to leverage this. It also helps out with another system called the Check Grounding API. All of these APIs are available across Vertex. We have maybe hundreds of repositories on GitHub that you can copy over and start working on that leverage these APIs. Typically, you would do it with a REST call. But the Check Grounding API determines how grounded a piece of text is. And it gives it a reference text called facts, so like the ones at the bottom of the answer, and scores it. So what you can do here is you can check if your RAG system is actually working well against the Check Grounding API. You can say, this is the question, this is the answer. Check Grounding API, what's the score for this? This is the question, this is the answer. Check Grounding API, what's the score for this? So this is one good system to make sure that your built application is functioning well. Finally, we talked about Agent Builder on the generation, not the generation, but the ingestion part, where you point the data store to data, and it creates the embeddings, it creates the entire data store for you. But then when it comes to the other areas, so we talked about ingestion here, retrieval, generation, and serving. All of these are available within Agent Builder Search Agent, which within the query retrieval uses Google's own algorithms for search on LLMs. It also has summarization for the answer generation in addition to serving controls. So it takes care of the front end, the load balancing, the auto scaling. You don't have to do anything. The main thing you have to do is point it to your data and make sure to tune the system to your functionality. But who wants out of the box? Everyone wants to do DIY. So when it comes to these other systems like LangChain, Llama Index, we as Google contribute a lot to it and make sure that it integrates well with our Vertex AI platform. So if you're expert in either Llama Index, LangChain, or if you're comfortable with out-of-the-box Vertex AI, all of these are supported, and all developers are free to use whatever they want to use on GCP. In addition to that, we have something called RAG Engine in case you have, you're comfortable with Llama Index, but you want a more managed Llama Index setup. So you want to be comfortable, you know the code, you know how to approach it, you know how the library works. Actually, So with Llama Index on Vertex AI, Llama Index again is a data framework for developing a RAG or context augmented large language model system. And RAG engine extends that with the SDK using Vertex AI SDK and the Llama Index framework. And then of course you can use the same kind of code that you would leverage in Llama Index. And if you can see the code over here, so define a variable, use the tool that imports from RAG, store the data, supply the files of the corpus, do the top K or top ranking, do a vector distance threshold, and then create a response or from a model. So in this case, in this code snippet, what we're creating is an endpoint of Gemini 1.5. And then, of course, I'll start serving using that. And then when it comes to the RAG engine, these are the common databases that we, by default, support on it. These databases act as the vector database. The default one is RAG Managed DB. It's just abstracted for you. But of course, if you want to use something like Pinecone, Waveit, common in the public, in the open source community, or vector search and feature store, which are supported and completely managed by Vertex, these would be supported within the RAG engine to help you automate your setup very quickly. Another thing that is within it is the reasoning engine. So reasoning engine provides a managed runtime for customized agentic workflows. A big part of agents is the caching, the memory, the long-term, short-term. And it uses kind of the full system provided to you by default, completely managed by Google Cloud. All you have to do is make sure that you stitch things together. And it takes care of the privacy requirements, security requirements, which if anyone, I've run into a funny story actually, where a customer was building their own DIY LLM, also a RAG system. And they discovered that all of the company's confidential data, which is restricted, even the executive data, that is restricted only to the executives, is accessible for every single employee in the company. Not even all employees, even if someone from outside comes and logs into their application, he'll be able to figure out what's their next quarter forecast, how much they're selling, how much they're doing, all of this. And that's because when they approach the DIY path, the DIY path is all about, let's finish quickly, but it's not enterprise ready. Enterprise ready, if you're building a startup, if you're building an application, or you're building an enterprise application, you have to make sure to account for the security of your customer data and the security of your own data. So that's why using systems like this, like the Reasoning Engine API, helps massively in avoiding these issues and gets you faster to market. So when it comes to the development workflow of it, these are the kind of the code snippets that you would typically go through. First, in developing, you would, for instance, define a class that's called agent, initialize it, set it up, define the query, what kind of setup, put a variable for the agent itself. Still, no API calls, right? I'm still developing. Initialization happens. I deploy the agent. The remote agent I can create against the reasoning engine and then map it to my local agent. And what happens here is that the agent itself that I just created will be able to go and call the Reasoning Engine API. And then it moves forward to the setup, where I would get the instance of that remote agent and start querying it using the queries that I got from my user. But the local agent here is local as in it's representing that remote agent. And then I can manage, of course, the reasoning engine by using the typical .list methods. All of these methods are, of course, documented very well in our documentation. And then finally, I can go and delete it. So the full life cycle of the development workflow can be done all by using the reasoning engine. Final thing I want to share, around the evaluation. I think after this I have a summary. Actually, let's go back. Okay. So evaluation is very important. Typically, we talked about the thumbs up, thumbs down. This is where I get the users to do my evaluation. Sometimes I would get the developers to do the evaluation. They would run a few queries, check the answers. Okay, good, bad. But that's not sustainable. Because if you spend, I don't know, let's say if you spend 3 hours on an LLM application, trying to figure out or evaluate whether it is good or bad, you'll probably maybe cover 3% of the cases, not even the full chunk. I mean, we know a lot about, we've all experienced AI, we've all used ChatGPT, Gemini, the rest of the Claude, it doesn't matter, all of these in the market. And you run into these issues. You see bad responses now and then. But when they launch, they're massive, massive companies. When they launch, before they launch, they have a rigorous evaluation process. Typically by hiring, we've seen it in the news. Some hire a lot of human beings somewhere in the world. Here's my AI, this is the new version, test it out. But I don't think anyone in this room, I mean, I'm assuming, has access to thousands and thousands of humans who can test the product for him or them before it goes live. This is where evaluation systems come in. So Vertex Model Evaluation Service is a critical product. Of course, some alternatives exist as well in the market, but this is a critical product to help you in evaluating the model before going into production, before releasing it. So there's the mode of doing online evaluation, which is a few instances. You set it up for the LLM, a couple of them, and then you start going through quick iteration, prompt, response, prompt, response, prompt, response, and then you start ranking it. There's also pipeline evaluation, auto SX and computation based, where you have many instances evaluating the model, and it has like an asynchronous workflow. Of course, a lot of templates exist to help you with that. I think developing LLM applications, especially right now, is very confusing. It's almost, let's say, it's almost like everyone's saying gibberish. And like most of the things that come out, after a week, they're deprecated. They're no longer useful. If you hear the keywords that get thrown around in meeting rooms, in schools, universities, online, every week there's a new term, every week there's a new tool, every week there's a different thing. But what I want you to get out of this session is the architecture remains the same. The LLM or the large language model is inherently lacking. It is always a point in time. Who here knows how LLMs get to be? Like how the training process and all of this? If I can get maybe someone to share what they think a large language model kind of goes through the factory to get produced at the end. No hands. Okay. But was that a no? Okay. There? No? Okay. Just double checking before I digress into this huge area. So a large language model typically is empty brain, nothing, no weights. It's a multiple layers of like numbers, representations, and not a vector, but just parameter representations. And what typically happens is that you take this architecture of empty values, and then you run it through a training pipeline. The training pipeline usually takes like the English corpus or something like this to train the model against the language for it to understand the language and generate that language. And then of course maybe you have a bigger data set, you fine tune the model or you train it in more data. But then once the training finishes, that's it. So if the training finished yesterday, I only know up to yesterday. I cannot know what happened today. Maybe today the entire internet broke. Maybe today, physics broke or something like that. Humanity changed. I would not know that. And training, that process takes millions, if not billions of dollars of expenditure by most companies to get to that level, which is still lacking. Because the moment you finish that training, the moment you're done spending billions, your model is outdated already, which is a very difficult thing to justify to investors. And that is why you don't, when the large language model hype and gold rush started in the beginning, so many companies started around, I'll train my own model, I'll do my own model, I'll do my own model. And then bit by bit, all gone. Now you only have the top kind of companies who are able to spend those billions of dollars because they have free cash to be able to reach that level of maturity with the models. Yet still, their models are outdated the moment that the training is done. So when I say that things are, let's say, the model gets outdated so fast and things change every day with the ecosystem, one thing doesn't change, which is architecture, which is a very, very important thing to understand, because architecture is to an extent theoretical rather than practical. In theory, the model will stop learning the moment it stops training. In theory, I cannot ask my investors for billions and billions of dollars every day to retrain my model and retrain my model. Maybe I can do smaller training runs, which some companies do. Still, it's not efficient. But that's why architectures like RAG come in to kind of reduce that expenditure by huge, huge amount. Some models stick with their training data set that for like months, because what they do is they improve their RAG system rather than spending money on the training system. Of course, because the industry is fast moving, if you've noticed, one of the biggest changes or improvements that happened in large language models wasn't better training or more money. It was an architecture change of the model itself. And we all know, which model came out and started, creating a big fuss in the market, like DeepSeek, for instance. They came out, lower training budget, and different architecture, and they beat everyone. And then, of course, everyone else followed suit. So now the idea is behind making sure that the architecture is right rather than spending more money on bigger hardware, more hardware. If you have your architecture right, you'll have your training right, you'll have your application right, but then you don't stop there. You have to make sure that you're fully embedded, no pun intended, across the system, across the community, to learn about new architectures that are coming out. And of course, to learn about some of the tools that are available to do your DIY, kind of do-it-yourself path. Like LangChain existed a long time ago. I think maybe at the start of the fruition of LLMs. And not many people were using it. Now, after many vendors, many big companies start creating their own out-of-the-box kind of system, people are going and reverting back to LangChain and LangIndex because also the open source community is developing a lot faster than these companies. And this is why at Google, we really believe in that open source community and we're contributing heavily into it. So again, I would re-emphasize, make sure to focus on the architecture. Make sure to focus on all components around your LLM before going into the LLM. Many times I've heard of large language model implementations or deployments where a lot of the users are complaining about using higher end GPUs. I need to spend more money. I need to spend this and that. And then when you go look at the architecture, their embedding system does no re-ranking. It only does generation once. They don't do fine-tuning on the embedded model. They don't know how to optimize their vector search. Their generation, they're only using one model to generate the answer rather than making a combination of different models. So the focus on making sure that your architecture is right before making sure that the LLM that you're deploying is good or up to the task is more important than trying to ask for more money and spend on training it or fine-tuning it. And after this kind of monologue, I'll kind of summarize what we've discussed so far. So if you want to build a RAG system on Google Cloud, you have several options. The out-of-the-box path, which is using Agent Builder that does everything for you. Storage of the data, vector representation, embedding, retrieval, generation. Or maybe you want to do it yourself. Also on Google Cloud, you would build your agent application using Python or any language that you're comfortable with. You have a generative model, whether it is something that's hosted by a, let's call it the Gemini API, or whether it is like an open source model like Llama deployed on GPUs. Then of course you would use an embedding model, so you can combine here whether you use embeddings API from Google Cloud, whether you deploy Qwen 3, for instance, on Google Cloud as an endpoint that you call for your embeddings. Then your vector database, that choice matters a lot. Back to that slide that we talked about, there's so many, there's like tens or 20 different options when it comes to vector databases. Making the right choice here. And of course, query rewriting to make sure that when the question comes in from your user, sometimes the users don't know, they're just talking to it like, it's like Google search. I mean, if you look behind the scenes and see the Google searches that happen, it's kind of funny. But this is also the same with LLMs. You'll see the exact same thing. Users don't care. They'll just say something like, what do I want to eat now? And it's just this random question, and they expect that you answer it. And then, of course, the LLM will not know how to answer it, and they will give it a thumbs down, go on the Play Store and give you 1 star, and of course, destroy your entire business. But doing something like query rewrite and spending a lot of engineering effort here is definitely something very important. And of course, re-ranking based on the answers, based on the user feedback, definitely something very important. So if you notice, we have 1, 2, 3, 4, 5 components that you can optimize, engineer, and make sure that your application gets up to speed versus one generative model that will just spit out English back into the portal with the user. And then finally, what if you want to do a mixed path? That is something also possible. You don't have to restrict yourself one way or the other. You can go use out-of-the-box tools, like let's say the data store and agent builder or vector search, which is available on Vertex AI. It does the vector DB for you, and it uses the algorithms that Google search uses. So these are proprietary algorithms. They're only available in this vector search system. And you can leverage it to make sure that you retrieve your embeddings the easiest and fastest way possible. And of course, your agent app can be built in whatever. The generative model here in the mixed path can be whatever model you want. And then the query engine also can be Llama index if you want it, or anything that's available in the industry. The data sources, most of these are easy to work with. I would say the most challenging ones are probably websites, because crawling a website is not super easy. It can break very fast, especially because you're relying on third parties. You're relying on websites. Wikipedia is written in a certain way. Google search is written in a different way. YouTube is in a different way. So you have to make sure that when you're doing the web crawling part, to make sure to engineer it very well. Because the system, unless you're doing it out of the box, if you're doing it DIY, you'll have to spend a lot of time on this. I think it disconnected. Let me just make sure. Okay, good. Another thing that's very difficult is images, probably. Images and videos. Why is that? Because doing images and videos means that this model here also has to understand images and videos. A lot of the more recent models are multimodal. When someone says multimodal, that means the model itself will understand images, will understand videos, and all of this. So don't try to overreach. If you're doing your first project through RAG, stick to text, then move over to maybe images and other areas. So if I had to rank from easiest to hardest, number one, start with text, get the system working, get the LLM working. Don't go and deploy your own model. Go use Gemini API, go use any of the common APIs that are already hosted. When choosing a vector database or embeddings model, for the vector DB, try to go for something managed. There's a lot of managed solutions out on the internet, or you can use vector search on Google Cloud, which is also available in Vertex. For the embeddings model, you can either go and experiment with the things that I just mentioned, like Quinn3, for instance, going and deploying it on a small amount of GPUs, or using the embeddings API from Google. And then finally, the query rewrite and re-ranking. This is something that you have probably spent a lot of time on to understand and configure properly. And then when it comes to the data sources, stick to text, then images, then videos, then a combination of all three. Otherwise, you'll have a bad time. Final thing is, don't over-engineer the system. There's a lot of representations of this architecture. We have a huge documentation on Google Cloud documentation around how to build this architecture. A lot of quick start guides with code snippets. You'll be able to copy it, configure it the way you want, customize it, and deploy it. I would also recommend that you experiment with something like Agent Builder to compare it against your project, right? One challenge around that is that Agent Builder is not currently available in Saudi Arabia. It's not available in our region. So typically, a lot of our customers use the custom approach with, for instance, the embedding, the vector DB being vector search, which is available in Saudi Arabia. And then some of the re-ranking, query rewriting, and embeddings models, they would use Quinn3. Generative model, they would use something open source, deployed on GPUs. The agent app, they would develop something on Python, using some of the common frameworks that are out there. And then for the data sources, all of these are available in Saudi, so they would just store all of them here and go through the entire mix. And with that, I'll pause to take any questions. I know it's been a lot. I know the topic is maybe not quite straightforward, but I hope I articulated the way that it works very well. I hope you took something out of this, because definitely this is something I even myself struggle with. I'm not gonna pretend to be the world expert on this. There's probably, a lot more people at Google who would be better suited to share with you and maybe represent this. But this is maybe my 5-year-old representation or sharing of this kind of knowledge that I've gathered across from different Google colleagues, from different experts, from AI specialists. And it definitely becomes a lot easier to understand when you think of the LLM as a child that does not have much information. So you always want to give it an open book exam, just to make sure that it does not mess up during the actual real world application of it. So therefore, I'll pause. I know we have 6 more minutes until the live stream. So if you have any questions, please raise your hand and go ahead. Any questions? Oh, go ahead, please. As
the 0 ones, because you mentioned stock number, so is it the same as the 0 ones?
Oh,
Like the machine in the language.
No. It's so that's a good question. Not binaries. They're not binary.
Yeah.
They're the vector representation would be presented in like parentheses, comma, 6.5, 7, 8, something like this. It's like a full number, right? Not a binary number. And then the way it would get represented in the column itself it would be in the three-dimensional kind of phase. Even some embeddings or vectors would be 0.72 from between 0 and 1, between 0 and 1, between 0 and 1. But still, it's not binary. They have to have, they're more granular, right? And actually, this is something I can probably show you.
But it shares the concept of the machine language. Like the same concept.
Of the machine language?
Yeah.
Yes and no. It's the vector representation is only understandable for the embedding model. So when you say hello, I am the embedding model, I will generate it as numbers, right? But I am the only one who understands what those numbers mean. No other embedding model, no other computer will understand what those numbers mean except me as the embedding model because I generated it. Yes, there is an algorithm that's generating it in the backend, but it is not something that would be comprehensible for any other machine or even other embedding models. Maybe even this, if there is another version of me, like let's say I'm using Gemini embedding API and Gemini embedding API. Each instance is a different version. So the numbers representation will be completely different. But I'll show you here. Actually, I didn't have the representation of it in the slides, but definitely this is something that we probably would like to see. A second. Yeah, this is a good image to represent it. Second. It will load up. So it looks something like this. Zero 0.0002, 0.56, and this is all outputted from the neural network itself or from the embedding model. And then these same numbers, when I send the question, they also become numbers similar to this. They might be 0.2. So in the 3 dimensions, it's maybe a little bit above 0.1. So the answer, when it comes back from the LLM, it will be similar to this. It's kind of similarity search. But the representation is like this, and any other embedding model will not understand what this means. Yes?
So you mentioned rewriting. When would that be?
I mentioned?
Rewriting.
Ah, yes.
So does that mean when I have like more words with embedding model, I don't know how it works.
Good question. So at what stage do you start re-ranking? So stage 1, you get the data sources, you generate the embeddings from the embedding model, you start in the vector DB. You can start re-ranking once you start testing the system. So you can start asking questions, and if you see that the similarity search is wrong, the answers it's giving you is off track, that's when you start re-ranking. You say the response is good, the response is bad, the response is good, bad. So you can do it in the evaluation, or you can do it live. You can open it up to the users and see, tell the users, evaluate my system. But it typically happens maybe at the later stage or the last stage of before going live with the model, at the evaluation stage.
So when the ChatGPT gives me 2 answers and asks me to give a thumbs up to one of them, this is what they're doing?
Yes. In the backend, you're taking that and like, okay, these got a yes. We also gave another user the same kind of answer at the same time, and that guy gave him a thumbs up. That person gave it a thumbs down. Okay, 90% of people like it, rank it up. The same thing we do with the Gemini as well. Yes, and also, this is kind of also another representation of it, the map meaning, the 3 dimensions. Like for instance, one vector number can represent movies, the music in the movie, and the actors in the movie. And these can be points in time in the dimension. So it's more of like a mathematical representation rather than a binary kind of representation. But yeah, definitely. So again, this is from GitHub, which is within our repository has the whole full code to develop or deploy your own RAG system. Okay.
So those embedding modules, do they support Arabic? I assume they do somehow.
They do. That's an interesting question because I'm not sure how big is the effect of language when it comes to embeddings. Typically, most of these embedding models are trained on Latin. So if they're doing the chunking based on letters, it doesn't matter. But if they're doing it on full words, it does matter. And yeah, some embedding models, you would see the Arabic kind of scoring against it. So you would have to check against that. And that's why one of the top ranks is Gemini and Quinn, because they do well across all of them. But that is a very interesting question because I do think that language doesn't matter as much in embeddings as it does in the LLM itself, like the big model that you're deploying. But definitely.
It is how much Arabic data was trained.
Exactly.
I assume much less than English languages.
A lot
This
less.
is like assumptions.
It's accurate. It's accurate. Very, very easily you would see everywhere leaderboards for English and Latin based models, but if you try to look for Arabic, there are very little leaderboards you would find it, and that's because a lot less models are trained on that. And one big reason behind that is because of if I'm spending billions of dollars, would I go train it on English, which is going to be 90% of the world, or would I focus it on Arabic? So it's like a comparison between the cost, which again, I mean, from Google's side, we're working heavily on leaning towards the Arabic improvements for our models. I mean, even I don't know, is the stream still on or couple stream? Back here, okay. Huh? Okay. I'll leave it for later. But yeah, it's definitely something that a lot of companies are working towards improving in the future. But yeah, very good questions. Any more questions? Raise of hands.